Hi, my name is Lewis Barlow. I'm a Fellow of the Institution of Civil Engineers and a specialist in whole-life carbon management. Decarbonisation, as we all hopefully know by now, is vital if we are to avoid catastrophic climate change. However, it's also a huge and potentially daunting subject area. So here are 10 key points that I hope will help you to maximise the decarbonisation impact of your work. Since the publication of the Infrastructure Carbon Review in 2013, we've known that most UK greenhouse gas or carbon emissions result from infrastructure. From constructing, operating, maintaining and using all kinds of infrastructure, from water to energy to transportation. Civil engineering is essential for designing, planning, constructing, operating and maintaining infrastructure. Therefore, civil engineers must play a key role in reducing greenhouse gas emissions. There's an unhelpful preconception that decarbonisation is just an environmental issue, therefore it's the responsibility of environmental specialists who often, at best, are only on the periphery of a design team. We need to recognise that the assessment and management of carbon in infrastructure is an emerging civil engineering discipline that makes the most impact when it's fully integrated into the design process. In 2019, the term net zero was formalised through an amendment to the Climate Change Act. Net zero means reducing carbon emissions as much as possible, then achieving a net zero balance by extracting the remainder from the atmosphere using either natural or technological means. The net zero to which the Climate Change Act refers is whole life carbon, the big carbon picture, including embodied, operational, maintenance and end of life. Nothing can be left out, and we can't be selective about our net zero carbon definitions. We already have climate policy in place, and it's our role as engineers to deliver on that promise and ensure sustainability. The Sustainable Development Goals were adopted by the United Nations in 2015. These 17 goals represent an urgent call for all countries, developed and developing, in a global partnership for sustainability. Goal number 13 is climate action, and within that goal are the twin issues of climate change mitigation and climate change adaptation. Climate change adaptation seeks to ensure that everything that currently exists and everything we plan for the future is suitably resilient to the serious climate change that's already coming, even if we stop emitting carbon tomorrow. Climate change mitigation, or decarbonisation, seeks to reduce carbon emissions towards net zero in an attempt to prevent catastrophic climate change. Decarbonisation is a prerequisite to sustainable development and should be seen as an engineering discipline in its own right. For example, a project meeting agenda item entitled Sustainability won't have the same impact or focus as an agenda item named Decarbonisation. The UK Government's Green Book sets out Treasury requirements for achieving public funding for business cases, including infrastructure projects. A review of the Green Book was published in 2020, which included enhanced guidance on gauging the acceptability of projects, policies and programmes against the achievement of net zero targets. Under these revised Green Book requirements, the whole life carbon emissions impact of projects and programmes and policies must be estimated from the earliest stage and included in business cases, usually in tonnes of carbon dioxide equivalent. This carbon emissions impact must then be converted into an economic value using the UK government's carbon values measured in pounds per tonne. According to the UK government, the current economic value of sending a tonne of carbon into the atmosphere is £248, predicted to increase to £378 by 2050. The product of the carbon emissions impact in tonnes and the carbon value in pounds per tonne is known as the carbon emissions impact cost. That's also known as the abatement cost, or the cost of removing the carbon from the atmosphere that is a result of a project. This means not only that whole life carbon should be estimated from the earliest possible stage, but that lower carbon options within projects and lower carbon projects themselves have a higher economic value. We need numbers, not adjectives, to address the climate emergency and achieve net zero as efficiently as possible. Numbers, not adjectives, was a phrase used by the late David Mackay in his excellent book, Sustainable Energy Without the Hot Air. David explained that the book was written out of his anger with people misrepresenting renewable energy options by not deploying a consistent and transparent numerical approach. We need that approach now more than ever, as we're in danger of being distracted by false solutions and greenwashed products and services. It's our responsibility as engineers to cut through the waffle and help our countries and our planet accelerate towards net zero. It's a strange situation that despite being in a climate emergency, carbon is still the only major environmental parameter for which there are no project-based limits. There are controls, guideline values, and science-based acceptable targets for contaminated land, the water environment, air quality and noise, but gauging the acceptability of a project's carbon emissions against net zero is still a relative mystery. Projects that warrant an environmental impact assessment, or EIA, must gauge the impact of the project on the climate. However, this is often a meaningless process where the total emissions from a project are compared with the total emissions from a country, usually resulting in a conclusion of insignificance. Recent IEEMA guidance on gauging carbon significance is a great step in the right direction, and it also hints on future area-based carbon targets against which one will be able to compare project emissions to provide a more sensible comparison. In the meantime, it's foreseeable that the planning process will soon change to include requirements for both the whole life carbon emissions of a proposed development and their relevance and alignment with local, regional and national net zero targets. The Greater London Authority is already implementing something similar through its planning process and the Carbon Offset Fund. As engineers, we should prepare our projects and our clients for this by, at the very least, deploying best practice whole life carbon management from the earliest stage. So what is best practice whole life carbon management for infrastructure? Cue PAS 2080 Carbon Management in Infrastructure. This PAS, or publicly available specification, was written in response to the guidance gap identified by the Infrastructure Carbon Review. Infrastructure is responsible for most greenhouse gas emissions in the UK, and yet until the publication of PAS 2080 in 2016, there was no consistent way of managing those emissions. PAS 2080 emphasises the importance of all parties across the value chain in collaboratively working towards a common carbon reduction goal. The procedure is relatively straightforward. Baseline your carbon emissions at the earliest possible stage, set carbon reduction targets, and proactively manage the process. PAS 2080 has been recently updated to include additional information on, for example, procurement and system-level carbon management. Its applicability has widened to the entire built environment, and it's set to become the way to manage carbon on construction projects across the UK and around the world. The successful application of PAS 2080 shouldn't just reduce carbon, it should also reduce cost. It shouldn't just be seen as the best way to reduce carbon on projects, it should be seen as the best way to choose the right project. There's a strong relationship between carbon and cost in infrastructure. Carbon is a proxy for energy, for the use of natural resources and quantities of materials. Reducing carbon, therefore, usually reduces cost. The UK government promoted this message in its Infrastructure Carbon Review in 2013. The report emphasised the importance of tackling carbon as early as possible on a project. As with cost, the greatest potential to reduce carbon on a project is at the beginning, when the most influential design decisions are made. Conversely, if left until later in a project, fewer options remain to reduce both carbon and cost. Reduce carbon, reduce cost is really the main message of the Infrastructure Carbon Review. a message that was intended to reassure stakeholders that lower carbon options wouldn't result in lower levels of service or increased costs. This negative perception of carbon reduction is gradually lifting as empirical data from real projects is being shared around the industry. Efficient design can reduce both carbon and cost to a certain point. In the past, a low-cost solution that achieved project objectives would have typically been regarded as a success. However, an increasing number of lower carbon options are currently available that cost more than traditional approaches. For example, quantities of concrete can be reduced to minimize both carbon and cost, but once an acceptable volume has been decided upon, the lowest carbon concrete currently costs more than traditional mixes. As the language of carbon cost becomes more prevalent and problematic carbon cost tipping points are identified more frequently, there will be increasing pressure on driving innovation and challenging current standards that put a premium on lower carbon solutions. As specifications such as PAS 2080 are used more frequently, the discipline of carbon cost management will formalize. Until then, a basic principle is that a carbon cost manager should be present on all design teams and involved in all decisions that will influence both carbon and cost. Carbon cost management will soon become a standard process, just as has the application of health and safety in everything that we do. In conclusion, we have top-down net zero requirements through the Climate Change Act and international equivalents, and we have an emerging bottom-up approach to minimizing carbon on our infrastructure projects, but a huge knowledge gap in the middle. How do we decide which projects best align with net zero? How do we decide which options within projects align best with net zero? How do we calibrate the importance of net zero against all the other sustainable development goals? Civil engineering is at the heart of the answers to these questions. We all must do our part as individuals, but collectively as civil engineers responsible for planning, designing, constructing and maintaining local, regional, national and international infrastructure, we have a specific responsibility to join the dots and ensure the sustainability of life on Earth.